Okay, continuing the 2017 old released STAAR test for algebra. We're on question number 21. This is a pretty simple question. It is asking about range. We know range is y. It looks like the g. So range is the y, all the y values that are being used. The line is going upwards. We see it curving up, so it's using all the y values above this point right here. And which one of these inequalities? Well, it certainly wouldn't have an x in it, so we can eliminate a and c. And this part would not make sense. The answer is B. Y is greater than or equal to everything above 250,000. All right, the next is talking about a sequence. This is a recursive formula. The long and the short of it is a to the sub n equals 4a sub n minus 1. And all this in a to the n minus 1, sub n minus 1, means is just the previous term. So you take whatever your previous term was and you multiply it times 4. That will give you the next term, a to the n, the next term. So just understanding this formula, all we need to know is each time it should be multiplying times 4. This is telling us that a sub 1, that's our first term, is equal to 6. So we should start with 6. All of our answer choices start with 6. That makes sense. And then what is our recursive formula telling us to do? To multiply times 4. So 6 times 4 is 24. And each one continues the same way throughout. Next question is talking about slope-intercept form that passes through these 2 points. The quickest and easiest way on that would be to graph these and then hit Control Table on the calculator. And we'd graph all of them, hit Control Table, and check to see if it goes through these points. If we were going to do it by hand, we could plug these points into each equation and test it. But I'm just going to show how you would go forward from the 2 points. First, let's find our slope. M is equal to y2 minus y1, x2 minus x1. So on this first point, we have x1, y1. It's our first point, so they're both 1s. And here's x2, y2. So we're going to plug it in. Negative 16 minus 47 over 2 minus negative 4. That's a key part to pay attention to. It's minus negative because the formula is minus and our x is minus. So it's minus negative, which is just like a big old plus sign on top of both of it. All right, what would that give us? It'd give us negative 63 over 6. And then if we reduce that, it'd be negative 21 over 2. We can take a look at our slopes. They're all the same. So that step, if you had noticed that from your answer choices, you wouldn't have had to do that, but it's always fun to find slope. Next, we take the slope that we just found or that you noticed was there, and we pick one of the points. I'm going to pick this first point, negative 447. That's our x comma y, and I'm going to plug it into y equals mx plus b. So the slope is going to go here, negative 21 over 2, and I'm going to plug in my y, 47, and my x, negative 4. So we just plugged in all the things we knew, our x, our y, and our slope, and now we're going to solve for that b term. That shouldn't have been a 5. We are going to multiply negative 21 times 4. I noticed, though, that this is like it's a fraction over 1. We can reduce, and that would be a negative 2, so it would be multiplying negative 21 times negative 2, so that's 47 equals 42 plus b minus 42 minus 42. B is equal to 5. So now we have our formula. We know the slope. Y is equal to negative 21 over 2x plus b. And in this case, the b is 5. We got the 5 from here. We got the slope from here. So the answer is C. All right. On this next one, we have to know what transformations of quadratics does. We've already shown in the first section of questions that this first number in front causes it to either be wide or narrow. It is wide when it's a number smaller than 1, like 1/2 or 1/3 or any decimal smaller than 1, and it gets narrow if it's a whole number like 2 or 5 or 10 or any number greater than 1. So it could be 1.2. That's greater than 1. It's a decimal, but it's greater than 1. So it is more narrow. Which graph best represents? Now, even when students understood what we've said so far, they still get tripped up on seeing which one the dotted line is and which one the new one is supposed to be. F of x, f is the original, the parent function. So if I look on this graph, here's f, it's the dotted line, that's the original. So we want our new one, the solid line, to be, since it's bigger than 1, narrow. We want it to be narrow. This one looks like it's narrow because it's inside it, but it was shifted up. It's still the same parabola. It was shifted up. It is not any more narrow. It's not F. This one was shifted to the right. It's not H. Here, the original, F is here. H is wider, so it's not that one. Here, the original is this F one. H is narrower, so the answer is J. Moving on to the next question. We have a word problem. Here we're told roses cost $3 each. They want to call roses X, so that'll be 3X plus carnations cost 2 each. They want carnations to be Y, so that'd be 2Y. And then here's the key phrase. She does not want to spend more than 30. So we know it's going to be 30 here. It's not an equation. It's not an equal sign. It's going to be an inequality. Not more than. So if it's not going to be more than 30, it's got to be less than 30. Now, the question, should it have an equal sign underneath it? Is it less than or equal to, or just less than? Well, it can't be more than 30, but it could be equal to. So it does need the line underneath it, and the answer is B. Moving on. Which one best represents the rate of change? Rate of change is slope. We should know that vocabulary word. We're going to find 2 points where it looks like it crosses. They're not perfect. This is an estimate, which one best represents, but those 2 look like they're good enough. We're going to go down 2 units, 2 squares, but how far is that really? It went from 10 to negative 10, so that's down. It's going by 10 on the axis. Down 2 squares would be down 20, minus 20, over... It was down 20. We know slope, m, is equal to rise over run. So it went down 20. That's minus 20. And how far over did we go? Well, we were at 1, and we ended at 4. 1, 2, 3. Negative 20 divided by 3 is equal to negative 6.67. And in our calculator, we could hit Control Enter to turn it from a fraction into a decimal. The one that's closest is F. All right, on our next one, we have a direct variation question. We know that because it says the words directly proportional. If it says varies directly or directly proportional, it's the same type of question. The way we're going to do this is by solving it as a proportion. You just put y over x equals y over x. You want to have that in your brain. Directly proportional, right, y over x equals y over x. Then we're going to plug in what it told us here. If y is 35, so we have 35, that goes where our y is, over x is 140, that goes where my x is, equals, what would it be? What would the value of y be? So we don't know what the y is, so I put a y there, when x is 70. So I put a 70 on bottom. And now we simply solve this. In order to get the y on its own, I need to get rid of that 70. Right now it's dividing because the fraction means divide. The opposite of dividing, the inverse, would be multiplying. So I'm going to multiply times 70. times 70. These 70s cancel. Y is equal to, and I would simply type that into my calculator, and it would give me 35 over 2. Since this is a griddable, we're recording it in bubbles, we need this as a decimal. You cannot put it in your griddable by putting 35.2. This is a fraction line. It doesn't mean decimal, and in the griddable there's only decimals that you can put. So it's not 35.2. You hit Control Enter and it gives you 17.5. That is the answer you would put in your griddable. Next, we have that same type of question that we've already done. You can either factor it or you can take your answer choices and distribute. I'll factor m squared minus 13m minus 30. A times C, we have a negative 30, we have a negative 13. What are the numbers that multiply to give us negative 30 and add to give us a negative 13? That would be negative 15 and 2. They multiply. Positive times negative would give us a negative, and when I add, I would have more of the negative 15 than the 2 after they cancel, and I'd have negative 13. Those two are what breaks up the middle section. So we have m squared, that stayed the same. The 13 is now negative 15m and a positive 2m. That's from what we got the factors, and our last term stays the same, minus 30. Then we group, and we bring out common factors. In this case, we have an m in both of them, so we'd factor out an m. We'd be left with m minus 15. In the second one, we can divide both by 2. We'd be left with m minus 15. We see the repeating binomial, so it's m minus 15 over, and the leftovers would be our second binomial, m plus 2. The answer would be F. Obviously, we could take our answer choices and distribute them. So I'll do that here. M minus 15, m plus 2. Then we would distribute. M times m is m squared. M times 2 is 2m. Negative 15 times n is negative 15m. Negative 15 times 2 is negative 30. Combine our middle two terms. M squared minus 13m minus 30. And we're given the same thing that matched. The final way, and I didn't mention this on the other one, and if you enjoy the calculator more than the other methods, you could easily graph this one and then graph your answer choices and see which ones match. You would get a parabola that's on top of each other. All right, our next one, it wants to know which one is passing through the points and how it compares to our original one. It's talking about a system. They've graphed one for us. We have to graph the other. So we should put a point at negative 12, 20. Left 12, up 20. And the other point is at 412, over 4, up 12. We draw that line, and we can notice that it is a parallel line to the original one. We can check the slopes. Down 2, over 4, down 2, over 4. So they are parallel lines. So how many solutions? There is no solution. They do not intersect. All right. Next, we're talking about domain. Domain, I see an x squared, so I know this is a quadratic. It's a parabola, and we know that for parabolas, the domain is always all real numbers. You could also graph that on your calculator if you could not just recognize that that was a quadratic. All right, we'll continue the next ones in the next video.